So first and foremost, thank each and every one of you for joining me. I do a lot of these talks. My name is Greg Pepper. I'm the head of engineering for our data center cloud and virtualization teams here at Checkpoint. Is the audio okay in the back? Excellent, all right. I was saying I have an opportunity to do a lot of these conferences and speaking at different conventions, user group meetings, industry sessions, and I gotta say, the session after lunch is the hardest. So thank you all for joining me today, and thank you for the time that we're gonna spend here for the next 45, 50 minutes talking a little about how we help our customers secure their migration to the cloud. Who in here has somehow got a company, an organization that's working on a cloud project, cloud initiative, right? You can't sneeze without stepping on cloud. So we're gonna try and keep the buzzword bingo to a minimum, I promise. But there may be a couple of TLAs and CFLAs that may be used today, right? The 3-letter acronyms and the complex 4-letter acronyms. All right, we'll try and avoid the really complicated 5-letter acronyms themselves. But when we look at cloud, it's here. This is not a new technology. Amazon's had their cloud for over a decade now. Microsoft a little over 5 years. Google's in the mix too. And if it's not public cloud that our customers are migrating to, many of you are thinking, well, how do we continue to enhance our physical environments? How do we move from traditional virtualization and static networks to this new software-defined network as well? And there's many drivers that people are moving forth. Some of us just want to quite simply reduce the amount of capital dollars that we're spending on servers, storage, networking, software licenses from security vendors like Checkpoint. For a lot of us, though, our computing needs are growing faster than we can source the technology. Let's be honest, there's a lot of layer 8, 9, and 10 in all of our organizations, and those are the people, the politics, and the money, around how you buy, deploy, manage, and maintain IT services. So as one of my customers said, and this was a large bank, he's like, look, we've got the money, but it takes me 6 months to buy a server. 6 months? I can do it in 6 minutes in Amazon. And he said, that's exactly why we're moving to the cloud, because we can do things faster. Now, it's not always cheaper in some cases. Sometimes you pay for the agility. You pay for the right to lease someone else's software. However, regardless of this, cloud is on this massive growth, and there's not a single organization that I talk with. And I have the opportunity to talk to our largest customers, our smallest customers, our public sector, our private sector, all of our industries, and every one of them seems to have some level of initiative and desire to move into cloud. However, every single one of them we talk to, security is a concern. Now, who thinks out of the box cloud secure, right? The cloud has security built in. I don't need to bring security with me to the cloud. I hear that a lot. And I would like to think that that's the case. But at the end of the day, the cloud is really no different than your own data center. It's just somebody else's computer, somebody else's network, somebody else's infrastructure, and you're just a tenant living in this shared services multi-tenant environment. Now, as we look to move to cloud, the two key things that we constantly hear from people is the ability to move faster, right? Like that bank that I talked about that took 6 months to deploy a server. The DevOps guys, they want to do it in 6 minutes. And they want to build it, destroy it, build it, destroy it 10 times within an hour or two. But equally is the elasticity. And let's be honest, every one of our organizations have those impactful events in our year. Maybe it's one of my department stores that has the biannual sale. Well, it happens twice a year. They bought computing resources to support that peak workload. Well, the other 50 weeks a year, they were running about 10 to 20% utilization. Who wants to pay for a lot of money for stuff to sit there idle for the once or twice a year that we need it? And this continues to be one of the primary drivers for cloud. So I want to move faster. I want to scale up when I need it, but more importantly, I want to scale down. Right now, our computing and our server and our infrastructure and our software guys get this. I'll be brutally honest, our security guys are the last ones to embrace this level of agility, automation, and elasticity. However, new demands are being put on IT. Let's be honest. Whether we want to or not, we have to support this application migration to cloud. Our companies are saying we want to automate and orchestrate and enable self-service portals and provisioning systems that allow our user population to have that Amazon-like experience, but do it in my own private environment. Use the tools that I've already invested in. And that is awesome. But let's be honest, who in this room has the resources of Google, Microsoft, and Amazon? None of us. Absolutely none of us. So it's very attractive to build upon their technology history, take advantage of all that they have to offer us. However, in order for us to truly embrace the cloud and move into this new software-defined world, we have to embrace what it offers us. Now, I'm not trying to sit here and say that the software-defined network is the answer to all of our data center problems. As a matter of fact, it creates new challenges and problems and opportunities, but it also provides a tremendous amount of power. And one of the things that we'll look about is how do we use this SDN capability, and whether we're talking about in the private cloud, maybe you're using OpenStack or NSX or ACI or Nuage or Juniper Contrail. Maybe you're moving in the public cloud and looking to use Amazon, Azure, Google, Rackspace, SoftLayer, Ali Cloud. I mean, there's so many options out there. But in each one of these situations, one of the biggest differences is that we've moved from the traditional static to the highly dynamic. Now, in the world of cloud, there's a lot of as solutions out there, right? We have our infrastructure as a solution, our traditional compute and storage and virtualized networking from Amazon, Azure, Google, and others. Right, we also have our platform services in the middle, where people are saying, you know what, I don't even want to manage the operating system anymore. I don't want to have to patch 100 instances of CentOS, Ubuntu, Apache, Tomcat. You do that for me. I just want to use those services, those microservices themselves. And in the far end, from a responsibility perspective, are those who say, you know what, I don't want to manage any of that. I just want to be responsible for my users and the data itself. Now, in each one of these buckets, the key takeaway is there is a shared responsibility. Right? What are they not securing in each one of these situations? Traditionally, your own IAM tools and the data that resides within it. Now, as I mentioned in the beginning, I work at Checkpoint. I've been here a little bit over a decade now, and I wear Checkpoint glasses. So there's a lot that we can talk about around CASBs, and a lot we can talk about API-level integration. Where I'm going to really focus our time is around the infrastructure side. And that's not to say that there aren't other security considerations for platform services and software as a service. Great topics, great conversations, but I only have an hour, technically 50 minutes. So we're going to focus on a little bit of what we really do well. Now, for those of you who know us, we were the inventors of the firewall. We've been doing this thing for 25 years. But let's be brutally honest, you can't bring your firewall with you to the cloud. Or can you? So when we talk about the cloud, we talk about the shared responsibility, most of us, we have a very similar environment. Right? We've got this hard, crunchy outside and the real soft, chewy underbelly. And I'm not going to embarrass anyone in the room and say whose organization looks like this, but I can tell you most of the banks, governments, healthcare, commercial organizations that we talk to, this is them. They bought every security technology from vendors like myself, and they've thrown them at the perimeter. And we're still vulnerable. We're still exposed. We're still at risk. We are still getting compromised. And worse yet, since we've only protected the perimeter and not done any internal segmentation, a very small infection becomes a very big problem rather fast. Look at Target a couple of years ago. Not to pick on them, they're a great customer of ours. But they have every security tool known to mankind. And the compromise of an HVAC vendor moved into a purchasing system and moved into a PCI system. And then they exfiltrated millions of our credit cards. And many people like you and me probably got a new debit card in the process, maybe 12 months of free credit monitoring service. Thank you, Target. But we want to be able to do things faster. And there's this ebb and flow between agility and our DevOps guys wanting to move as fast as humanly possible and those server networking and security guys that have been holding us back. And what we see in many cases is some of the application guys, they lift and shift and move to the cloud, and they say, you know what, guys? Networking, security, server storage folks, see you later. I'm going to the cloud. I can do this by myself. Maybe you can, but let's be honest, are your DevOps folks and application guys really security specialists? Do you think they care about the security of their applications? I would hope so. I mean, they're the ones responsible for it. But the other major change that we see here, back to the reason people go to cloud, is for automation and elasticity. So if I'm going to build this highly elastic application that can handle that twice-a-year sale. Or I'm a tax provider and April 15th is coming around the corner and I need to scale up my application. Or I'm an online florist and we're now going to take a whole year's worth of orders in 2 weeks right around Valentine's Day. Well, my solution has to be able to scale up. Now, it does no good to have your application scale and the infrastructure not scale. It does me no good to have 1,000 web servers in an auto-scaling group going through a single firewall. That sounds like a lot of packet loss and latency to me. Who here wants security with significant amounts of packet loss and latency? Nobody. Now, every one of you in this room are faced with many choices right now. Do we continue to invest in our traditional data center environment? It may be VMware. It could be OpenStack with KVM. You might have Juniper switches or Brocade and not Cisco. But the point is, you've got servers, storage, networking, and software that you've invested millions of dollars in over the last decade. And do we continue to invest in it? Do we enhance it with automation and orchestration, or maybe bring forth an SDN controller? I would say many people in this room, they're going to continue to invest in this dedicated infrastructure. And especially in highly regulated industries like financial services and healthcare, the more sensitive to data, right? Data is the new oil, as we learned this morning. The more sensitive to data, the more we need to invest in the security to protect it. Now, for some of our customers, the question is, which applications are we going to move into these public cloud providers? Amazon, Google, Microsoft, or other. There's many people out there, but those are some of the leading providers that we see. Or on the opposite side, how do we figure out maybe how to use more open source technologies within my cloud computing to drive down some of the cost? That is not an editorial statement that I think OpenStack is better than VMware, NSX is better than ACI, or vice versa. As a matter of fact, in many of our customers, you wind up with all of these. And what I find is the bigger the organization, the more likely it is that you're going to have every one of these cloud computing platforms on the screen itself. Just to have a little fun right here. Who's got at least 2 of these in their environment right now? All right, keep your hands up if you got 3. Got 3 different, all right, anyone 4? I only see 1 or 2 maybe. We're going to have a lucky 5. All right. Sometimes I get a 6 for 6 in the room. I don't have giveaway prizes. I'm sorry. Now, regardless of where we invest the technology, there's been this tremendous shift from static configuration management to be more dynamic and agile. Now, depending upon the environment that you have, the VM toolkit, the OpenStack toolkit, the Cisco toolkit, Amazon and Azure, there's 3 players I really want to introduce. You know, in the right corner is the cloud manager. This is your traditional vCenter, your OpenStack management systems. The traditional native consoles and portals of these cloud computing providers where we can provision virtual machines. I can give it networks, I can give it storage, I can attach the virtual machines themselves. And in the private cloud, you potentially have a couple of different options. Am I using Hyper-V or KVM, or using VMware as an example? Now, when we go to Amazon or Azure, you don't have the option to bring forth the cloud manager with you. Now, similarly, on the left corner over here, we have this new guy, this new up-and-coming welterweight champion of the world. This is the SDN controller. So you may be augmenting your private cloud, your VMware, adding NSX. You may have Cisco and be adding ACI. You may be looking at Juniper. You may be looking at Nuage or PlumGrid. There's so many people in this space as well. However, when we move to the public cloud, though there are some options to bring forth software-defined routers and things with you, you have to use the SDN that Amazon, Google, and or Microsoft offer to you. And it's actually one of the things that we're going to talk about, which is understanding the capabilities of their SDN and how it works, but also understanding some of the limitations. Because it is not possible for me to get into Amazon and not use the Amazon software-defined network. It is not possible for me to go into Azure and not use their SDN controller. Now, where we do have tremendous amount of flexibility and options here is in this guy in the middle, the orchestrator. Now, there's many vendors out there that make orchestration engines. We are not one of them. But there are orchestration engines that focus on the computing side. Some of them focus on the security side. Some of them are trying to do a bit of both. The key, though, is that this orchestrator now becomes the central place to automate and orchestrate configuration management in both the SDN controller, the cloud computing manager, and even vendor tools like myself or F5 or Citrix or Palo Alto or Fortinet or Cisco. Look, we all have a very similar management architecture. But the key is now this orchestrator is responsible for kicking off these workflows, these automation tasks. Now, there's many things that happen as part of these automation. Maybe we're just changing around the networking a little bit, right? We're modifying the load balancers, the routing, or the VLAN, or something within the network fabric itself. Automation could be used to scale up the application. All right, we've gone from dev to staging, from staging to production, and now I want to go from a small environment of a couple VMs to a large-scale production environment of dozens and hundreds of virtual machines. So tools like Puppet, Chef, Ansible, BMC Atrium, VRO, Cisco Clicker, I mean, so many tools out there can be doing these jobs for you, but they're going to cause changes in the network. And the security tools in the past have been perceived to be the bottleneck. Anybody get this complaint from your peers? Oh, we've done stuff, but we're waiting for the firewall guys to make the change. Maybe I'm the firewall guy. I hear it more than most. But the key is that the security tools have to change and adapt along with the changing nature of the infrastructure. I talked about in the DevOps world, we are rolling out and destroying entire application stacks in minutes. With automation, they live for a test case, we destroy them, we delete them, and we redeploy it in and of itself. Or even we talked a little bit about IoT this morning. As you bring forth all of these connected devices on the network, how do we enable the security systems to real-time learn about them? So let's look at a couple of the very simple automation tasks and what that potentially does for our security model. Right, so maybe we've got a simple VM IP address change. Although if this IP address now potentially moves into a different VLAN or place in the network, well, it may or may not have the access necessary to go live. So even though the virtual teams are finished with their work, the security teams now have to log in the firewalls, maybe make a change, push a rule base, or if the person put the virtual machine in the wrong security zone, maybe doesn't have access to the rest of the tools that it actually needs to. I get this question about 10 times a day. How do we reduce the amount of time, reduce the amount of times I have to log into the firewall and make a change? Who likes making firewall changes? Nobody. I'm the firewall guy. I don't want to make firewall changes, right? But the point is that it's going to change. And if we don't start to do it in a more agile and automated way, it just means an endless supply of tickets in the ServiceNow help desk queue that we have to go ahead and manage and maintain. Now, I talked about the scaling up. This is another perfect example, because this is not just a change to the firewalls. You might have load balancers sitting around your web farm. So not only are we adding 20 more web servers now, we not only need to update the firewall and the IPS rule set, but maybe the load balancer needs a configuration change as well. And this could be a third-party load balancer like F5, Citrix, Avi Networks, or other. This could be the native load balancers built into the public cloud. The elastic load balancers in Amazon or Azure or Google as an example. Similarly, there's a cause and effect. We've changed the computing environment. The security model has to change to match it as well. And the key here is if automation orchestration started the change, shouldn't it be able to complete the change all the way through the stack itself? Same idea with an entirely new application stack. Especially in the cloud, it is not uncommon for our customers to build and destroy a VNet or a VPC, the logical containers of compute, storage, and networking, in the public cloud multiple times a day. They spin up the web servers, the app servers, the database, they do all the automated connectors, they set up the security groups. Well, couldn't and shouldn't the firewalls and the security controls come alongside with it? And this is not a specific to Checkpoint thing. This is every one of our security vendors should be offering these automated ways, the zero-touch way to deploy security as a service at the same time that our DevOps folks are deploying the infrastructure as a service. And this is the evolutionary journey that I like to help our customers with. Most all of us, we're definitely here, right? We've got VMware, we've got virtualization, and I've yet to meet a customer that doesn't have some small private cloud environment. Now, whether or not they're actually augmenting that by bringing forth an SDN controller, that varies. You know, flip a coin. Some are all in, some is not the right thing. However, every one of our customers is trying to move into this automated and orchestrated way. Clearly our largest of customers, when I'm talking to that very large bank in America or that very large bank that has thousands of devices, you can imagine they need to automate and orchestrate. They cannot manage thousands of security controls without automation and orchestration. On the flip side, when I talk to my school districts that have one or two people managing everything, they need to automate and orchestrate too. They have very large networks with very large infrastructure and only a handful of people to help them deploy things. So it doesn't matter if I'm talking with the local school district, K through 12, community college, regional healthcare providers, every one of our customers are trying to move in this direction. And the challenge for us as security professionals, let's be honest, is that we have not always embraced all the levels of automation and orchestration that's out there. This is not new technology. However, automating your securities for firewall and IPS and proxy and DLP and encryption, this is where I think many of our customers are moving into new frontier. So let's pause for a minute and take a look at some of the leading cloud providers. And I mentioned we're going to focus on the infrastructure side in this conversation. Again, one, I only have 15 minutes, and two, we got to really focus in on things that we can help with. So first and foremost, the deployment of security in today's software-defined world takes on a whole new mechanism. No longer is it just about buying a box from a vendor, racking it up, plugging into a couple of ports, and going along with configuration management. As a matter of fact, in today's SDN world, there are no boxes. There are no 1U appliances with console ports and a management port. Everything is software-defined. Now, we use very different terminology to describe the same exact thing. And the first step is, how do we give birth to these security instances? The day zero deployment, as a lot of my telcos like to talk about. Now, in Amazon, they use CloudFormation templates, which is really just a fancy JSON file. In Azure, they use ARM templates, same idea. Only naturally, if you're Microsoft, you're a little bit more PowerShell-centric in some of your deployment. If we're using VMware, we can create vApps. And if we're using OpenStack controllers, we can use Heat and YAML templates. Regardless of what name we want to attach, it's the automated deployment of the security. It's the giving birth of the instance. But also, it is the day one configuration management. Now, in some cases, we can bootstrap this information and seed it into the deployment of itself. This way, when it comes out born, it's got all of the characteristics that it needs. AAA information for authentication and accounting and authorization. Might have the SNMP information, or the role-based access control information, or the syslog and the NetFlow information. All of these things, however, are post-deployment fix-ups, right? We deploy them in the basic configuration, and then we seed into it our own level of configuration. However, as we'll see in a moment, in today's SDN world, even if you've deployed the security, and this is not a checkpoint thing, packets will never hit our devices unless the SDN controller sends the packets our way. And this is both the challenge and the opportunity that SDN presents for us, is that it's very easy to deploy in the cloud. However, you have to determine what is the traffic I would like to be able to send into these cloud instances. Now, in the public cloud, Layer 2 behaves a little bit differently than it does in the private cloud world. But equally, based upon the compute instance size that we've purchased, it's not just cores and RAM, but you also notice these little network bandwidth columns. It's funny, I love when I get the question from my customers, you know, what's the 10 gig cloud firewall? Like, well, there really isn't a 10 gig cloud firewall. We can take many firewalls and put them together. However, in our largest instance type in Amazon, if I put my firewall on a 36 core instance, they're going to put a network policer around that at 4 gig. And this is a good thing because they're protecting themselves and they're protecting you and protecting me. They don't want a small instance to exceed that rate, right? They don't want that Ford Focus in the highway trying to do 120 miles per hour up and down the 95. And I've seen some of you drive. I know who you are out there, okay? But in the public cloud, we have to understand that performance is going to be dependent upon the instance that we put on it. It has nothing to do with how fast my firewall is and whether or not PAN's faster than me or if I'm faster than Fortinet. Because on a 2-core, 4-core, 8-core, 16-core instance, this is Amazon up top and Microsoft down below, they're going to determine how fast I can get there. But you're probably sitting here saying, well, everything's in the cloud. It's all 10 gig connected. I need everything to be 10 gig. Well, how do I get that 10 gig firewall? Well, remember, 10 times 1 equals 10. And 1 times 10 equals 10. And 5 times 2 equals 10. There's many ways to get there. And we utilize a lot of these load balancing capabilities and these auto-scaling capabilities to provide the incremental performance. Remember, this is not like your physical data center where you go from router to firewall and firewall to core switch. Everything is software defined and stitched together. So we use the load balancers. We use network address translation. We use different routing mechanisms to send packets in and out of the security devices in the public cloud. And again, it doesn't matter if it's a VSec firewall, a Fortinet firewall, a PAN firewall. We're all using the same set of infrastructure within the SDN controller to insert, not just for north to south, the basic perimeter, because again, let's be honest, that's table stakes. That's minimum entry point, is securing the perimeter. But where we really need to be going is securing inside of those applications as well. It's very easy to protect on the outside, but what about on the inside of the organization? Too often, a very small compromise of a server can lead to a very big problem. I'm going to tell a quick little story here that happened to one of my Amazon customers. So someone in the accounting department noticed an anomaly in the AWS bill. They were around $5,000 a month, and all of a sudden the next month they were around $10,000. Now, mind you, this wasn't the InfoSec folks that saw the anomalous behaviors. It was the accounting. So they did a little bit of research, and what they found was there was this rogue auto-scaling group that was created. Well, it started with one small instance, and much like we saw this morning with that MongoDB admin interface, I'm going to pick on my developers here, but they want to work from home. They just open up these ports to anywhere on the internet. They don't patch their systems, and all of a sudden now, one of these Apache LAMP admin tools was compromised. Well, next thing you know, people had root level access to the subscription, because the keys were there, and they created these auto-scaling groups to do Bitcoin mining. Which, considering Bitcoins are what, 2,000 Bitcoins or 2,000 bucks a Bitcoin? Not a bad deal, especially if someone else is paying for it. So what happened was they compromised the AWS environment. They set up an auto-scaling group. They're mining Bitcoins, and the next month, someone had a $10,000 Amazon bill and figured out what was going on. Now that was good. They're out 5,000 bucks. Although the question is, how did they get in? Well, at the end of the day, they got in because there was a very small vulnerability on an exposed admin tool that the developers thought, no one's going to hit this. Yes, because nobody randomly port scans the Amazon address ranges trying to look for vulnerable hosts. Come on. Of course, and we see it all the time. I mean, look, we put our firewall and our IPS in the cloud, and within minutes, we see hundreds, if not thousands of attacks coming in. People think, oh, I've got the Amazon firewall. It blocks everything but port 80 and 443. However, on 80 and 443, every single thing can get through it. All right? These are access control lists. Who would deploy an application on the internet, put ACLs in the router, high five and go home and call it a day? Nobody. It's comical. It's laugh. But this is what people are doing in the cloud today. They're just deploying basic ACLs and expecting it to be adequate. So I talked a little bit about routing. In the public cloud, everything is done through some type of a layer 3 service insertion. Even if you or I are two VLAN or two VMs on the same VLAN, there's a layer 3 controller that's allowing us to talk to one another. Now, I will say this is one of the major differences between Amazon and Azure itself. And we'll see in a moment, from a north to south, they're kind of exactly the same. We service chain the internet gateway. We route packets through a firewall. We maybe use some load balancers as an example. However, when we look at the east to west, one of the big differences you'll notice in the Amazon routing table, the subnet of the VPC cannot be overridden. So what that means is if we were all different VMs within the same virtual private cloud in Amazon, even if we're in different subnets, we are all one hop away from one another. Different availability zones, doesn't make a difference. We're all one hop away. And unfortunately, we cannot override this local routing table within AWS. Now, there are ways to do east-to-west insertion, but it is not as easy as it is, to be brutally honest, in AWS. AWS allows us to override the local routing table through the use of multiple route tables with different route prefixes, allowing us to override things such as the local VNet itself. So if we look at the basic deployment, and VNF is one of those virtualized network firewalls. You may hear virtualized network gateway. There's many different terms that we out there. And I happen to have my little icon in there, but again, you can put in your own firewall vendor of choice. We're not the only ones in the marketplace. We may be the best ones, but we're not the only ones. Now, from a north to south perspective, this is pretty straightforward. Right? We've got some type of a network address translation happening of the public web servers. Maybe there's some load balancers as well that we're using that handle the flows, and we route the packets southbound through the firewall. On egress, we do the exact same thing. We basically go into the route tables of those particular subnets, and we modify the default route to point at the ENI, the Elastic Network Interface of the firewall. Again, checkpoint, Fortinet, PAN, Cisco, we're all going to do the same exact thing here. Now, I mentioned from an east to west perspective, Amazon does this challenging thing that makes every VM one hop away from one another. And by default, it is not possible to route east to west overriding the local routing table. There are a couple of workarounds that one has, one of which is quite simple using simple network address translation. So let's play the very simple game. I've got a web tier, which is 10.10.1. I've got a database tier, which is 10.10.2. And by default, they're going to talk to one another. However, if we set up some bogus network address translation, let's call this the 10.10.11 subnet, and call this the 10.10.12 subnet. Now these subnets are external to the VPC. The local routing table says, I don't know this IP address, and I have a default route, send it to the firewall. Now these firewalls will do a variety of NAT trickery, source natting the flows, destination natting them back to the original, allowing this type of an east to west insertion to happen inside of Amazon. Now this is a good strategy for a single VPC. However, for some of our customers that have dozens of VPCs and now have to have the application guys use new address spaces to talk east to west, this can be a little bit of a cumbersome problem. All right. Now, within that, I mentioned that there's a bunch of network address translation and a bunch of NAT rules. And for those of you that are kind of in the network engineering world and are curious, well, what might this look like for me? Right? So we've got some public IP addresses, these elastic IP addresses, and they get mapped to some type of a private address itself. All right, one of which might be the gateway and the manager. Some of it might be the load balancers or the jump hosts or the terminal servers or however you want to get in and out of the environment itself. But it's important to understand these elastic IP addresses, these are actually NAT addresses that happen one hop north of the firewalls. Again, doesn't matter, checkpoint, Fortinet, PAN, Cisco, we're all the same. Amazon is providing this public network address translation at the internet gateway itself. So technically, all your firewalls will know about is the private addresses on the inside and or the outside. But you'll notice on the internal route table, we make the next hop default gateway of the firewall. Again, depending upon some of the public address translation that's taking place, you're basically going to route these packets in and out of the gateway. And this works very well for a simple architecture. One gateway, one VPC. Well, what happens if you've got dozens of VPCs or dozens of gateways out there? A little bit more complicated to do. I mentioned Azure. We kind of do the same exact thing. Again, we modify the routing table to send southbound traffic, or we utilize the Microsoft load balancers to handle a flow and then NAT it through the gateway to send it on to the web tier itself. And similarly, from an egress perspective, we're able to go ahead and modify the local route table and say the next hop default gateway is some type of a virtualized network appliance. Checkpoint or some other vendor out there. Now, where they're different is around the ability to override this local routing table. And this is not me saying that Azure is better than AWS or AWS is not as sophisticated as Azure. I'm just saying from a network security perspective, Azure is a little bit easier to work with, we find, because these locally defined, user-defined routes allow us to very easily not only provide east-to-west insertion between subnets, but even micro-segmentation within the same exact subnet itself. So if I was to apply some type of a user-defined route within the web subnet for the web subnet, it is going to now send every host-to-host communication up to the virtual network firewalls. Again, nothing to do with Checkpoint, everything to do with the Azure stack itself. All right? Now, similarly, I mentioned that we utilize those user-defined routes in order to send north to south or east to west traffic in and around the firewalls. Right? So it doesn't matter whose firewall you're using, we have to use the SDN controller. We cannot turn off the Amazon and Microsoft routing engine. We have to use it, so let's use it to our advantage. Now, I mentioned in the beginning that many people move to the cloud for the purposes of scalability. And autoscaling, or VM scale sets, is a very common solution that our application folks are using. Rather than having a single instance, it's a group of instances, and these groups can both scale up and scale down. Right? Now, it doesn't matter whose firewall you're using in these scaling groups, we have to utilize the load balancers to terminate the flows. So if you imagine www.mywebsite.com, it terminates on a load balancer, and in this particular case, it allows you to round robin scale across multiple devices. So just like you'll have a scale set or an autoscale group of web servers, you might have the same thing as a firewall. Now, what's nice here is that these firewalls automatically deploy themselves, they automatically scale up when you need more, and most importantly, they scale down when you need less. Now, this is not a Checkpoint magic solution. This is using autoscale groups. This is using CloudWatch. This is using Lambda. This is using a lot of native capabilities built into the cloud solution itself. Now, this works great on ingress. However, on egress, these autoscaling groups cannot become the default route for a particular subnet. So from an egress perspective, you can do egress proxy controls in a similar autoscaling fashion. However, for non-80 and non-443 traffic, for egress controls, you'd have to deploy some type of a standalone gateway device. All right? Now, this might be used for VPN tunnel. This might be used for outbound SSH monitoring. This might be used on an express route or a direct connect or some other mobile access solution. But the key here is finding the right tool for the right job. And what I always tell customers is, ask, what are your application guys doing? And if your application folks are using auto-scaling in the application, well, your security controls, whether they're Checkpoint or somebody else, should also utilize the auto-scaling functionality. If you ask your developers, are you using auto-scale, and they say, what's that? Well, let me go back to the more traditional static models. All right, if they're not building an elastic application, you don't need elastic firewalls. If they are building an elastic application, well, you need an elastic security solution to go along with it. Now, I mentioned that we've got the term of an autoscale group within AWS. Microsoft kind of does the same exact thing. Different icons, different names. Remember the different TLAs? They call it a VM scale set. But the same exact idea happens. We terminate www.mywebsite.com on some external load balancer. This now handles the session round robining to the firewall or the load balancer or the WAF or some other security device you may choose to bring with us. And then on the inside, we stitch it back to another load balancer. And that's then traditionally the one that's sitting in front of the web farm, right? The scale set that represents the web server group, which is potentially different than the scale set here, which represents the firewall group. Now, the key for all the security folks in the room who are saying, man, this sounds like a lot of work for me. The truth of the matter is that when we deploy this solution, it is zero work for the people in this room. It is automatically deployed. We're going to use those templates. We're going to use those CloudFormation, those ARM templates. And the DevOps team that's rolling out the automation orchestration should be responsible for rolling this out as well. And I think that's one of the key takeaways, in that many vendors like myself and others, we have APIs. We can automate and orchestrate virtually every element of the configuration management. However, I will tell you, having worked with many of our customers, and we have over 160,000 globally, I haven't talked to all 160,000, but everyone I talk to is saying, Greg, how do we automate and orchestrate? How do I decouple myself from these manual security processes that we have in place and enable this DevOps mentality to push into the InfoSec world as well? And what I'm telling the people in this room is that the technology is there. We have to embrace it. We have to use it and understand this mentality for automation orchestration. Well, there are others inside your organization that are already doing this today. Bring them into your projects. Bring them into your teams. You may not have the Python and the automation expertise on the InfoSec side. Someone on the application side understands it. Because when you set up the automation now, if I was a hacker, this would be my primary area of focus. I don't need to compromise the network if I can compromise the controller. Because if I can now compromise the automation engine, I can wreak havoc and inject major change into your infrastructure, which is why things like the IAM roles, the delegated permission, the role-based controls, it is so important. This is not a place where you can have one user, root, log in and do everything. And for those of you who still have those privileged accounts out there with these simple username and passwords, as we saw earlier on, change those passwords. Right? Let's not make it easy for the bad guys to do their job. All right? So let me try and wrap it up. We got about 5 or 10 minutes left here. What is the very simple plan that we provide customers? What do they want to know from us? And again, this is not a plan that's a Checkpoint proprietary plan, although we've implemented this with our customers dozens and hundreds of times. First and foremost, like any data center, we have to secure the perimeter. So we discussed no one's going to have basic ACLs out there. We need next generation security, whether it's myself or a different vendor. You have a question, sir?
Yeah, I'm just curious. This is all very interesting. You're suggesting that using a route table, a particular kind of network style control plane to manage east-west traffic. In many contexts, there's a complication doing that in that once you create a construct like that, a route table or you see some of the other kind of network control objects that are available from AWS, there's no way really to limit the use, the application of that structure by basically there's a very little you can do by IAM to limit the ability of anyone who has access to the environment to associate something they might be working with any of those constructs once they're created. So I'm just wondering if route tables are superior in any way to the alternatives for trying to constrain those structures.
Well, I don't know if it's superior. Actually, for a lot of our east to west, and the question was, the layer 3 route insertion has its own challenges. You're absolutely right, and let me back up. Most of our DevOps guys who are full root access within the VPC, that has to change.
Well, the thing is, you can have the lowest level IAM access, which allows you to run instances, to launch instances.
Yes.
And that is sufficient to be able to associate route table and ACL or security group that happens to already exist for someone, perhaps created for some completely unrelated reason.
Yes.
But within that context, everything that's already been created is a free option for anybody who has the lowest level access to that.
Sure. But this is also where sometimes we separate in different VPCs as an example to create additional role-based boundaries. The question, the comment was more, in these shared environments, it is possible if you give the wrong delegated permissions for people to bypass the security controls. I don't mean to summarize and put words, but that's kind of what I'm hearing. And that's absolutely correct.
Which is a shared environment, you can't actually differentiate permissions in a way that would allow you to segment basically the usability of different constructs like the ones you're describing.
Yeah.
If you created one for one purpose and you have others that you have defined for other purposes, if they cohabit in the same shared environment and you have people who have low level access to that, they can use any of it.
Potentially, absolutely. But again, this is where it's not just about getting the security guys into the cloud. It's understanding what are the swim lanes, right? What do I want to give the server guys? What do I want to give the networking guys? And how do I use those cloud tools to create those least privileged rights? Today, the application guys who set up the VPC, they've got full root level access for everything. And it's a challenge because they're not, let me say it differently. They went to the cloud to get away from guys like you and me. Let's be brutally honest. A lot of these cloud migrations are people wanting to divorce themselves from their internal IT groups. But there are ways for us to go ahead and create different swim lanes, use IAM roles, remove some of those permissions. But you're absolutely right. Depending upon the role-based permissions that are allocated to that user, they may or may not be able to choose a route table as an example.
There's no IAM permission set that actually allows you to access a thing that does not, that precludes There's no way to
All right.
have one without the other.
Well, let's talk offline because we're doing some project with Starbucks for that very thing.
That would be very
And, coffee company, to do very similar things. Now, I talked about the perimeter, right? At minimum, we start with edge firewalls, and hopefully, you somehow securely connect your on-premise data center into the cloud. Now, whether you use the Amazon VGW, the Azure VPN gateway, a third-party gateway, a Cisco gateway, I don't care. Just remember, MPLS is encapsulated, is not encrypted. So for all of my fancy pants out there who think that my Express Route and Direct Connect protects my data, it doesn't. It encapsulated it through the carrier network to get it into the cloud itself. But at minimum, we have to protect the perimeter and do more than just basic ACLs, more than just basic firewall. Step number 2, and again, it varies based upon who's cloud and who's SDN, is looking inside the network. Yes, I know we need to protect and harden port 443 in the web tier. What about the web to the app or the app to the database? What about the prod environment from the non-prod environment? What about the student information system that's carrying all my grades and admissions versus my Res Life, which is dealing with the cafeteria and the bookstore? Right, they're two different customers with two different requirements. They should not be able to talk freely amongst one another here. Right, it's those internal controls that in the future will help protect us from the lateral movement of an infection. Because let's be honest, we will get infected. There will be a breach. There will be a system that will get compromised. There will be an unpatched IoT device in your network sometime soon that at some point is going to access the environment. All right? Step number 3 that we talked about is the consistency of security. For some of our customers, an entire application moves out to the cloud. For some of our customers, the web tier moves out, but we still hang on to those MFers in the network. You know, the mainframes, right? Those MFers in the network that are never going to the cloud, right? That big iron database, that AIX, that Oracle Sun server that's still in the data center and probably is talking to some of the most important systems you have out there, right? So we need to understand what's the difference. How do we protect on-premise and how do we protect off-premises as well? And provide some consistency for you guys. Because let's be honest, there's a lot of great technology and most of my customers have bought 2 of everything and have struggled to maintain and manage it over time. Right? We get enamored with the shiny new toy syndrome or the resume enhancing syndrome. Lastly, 4th, we talked about it, automate. We have to be able to automate. And there's a lot of great vendors out there that focus on security automation, Tufin, Fireman, AWS, Phantom, and others. Right? There's many cloud automation and orchestration engines. We talked a little bit about Puppet, Chef, Ansible, VRO, VRA, Cisco Clicker, BMC, Atrium, on and on and on. But our server and our infrastructure folks are embracing this concept of automation and orchestration, and we need to harness their power, their capabilities, and their ability to automatically deploy systems and make changes and ride their wave. I really appreciate you joining us today. We talked a little bit about how do we enable service chaining in the cloud, whether it's private cloud, whether it's public cloud. But the key here is that the SDN controller is your friend. This is not just a networking tool. This is a technology that allows the automated service chaining of not just firewalls, but IDS, IPS, DLP, DDoS, SSL offload. There's many great technology out there, and SDN makes it easier to insert these security controls in the network. We talked a little bit about automation orchestration, and one of the key things, and I didn't want to get too much into it here, is how do we enable the security controls to automatically use things like tags and groups in Amazon and Azure. Again, the server folks are already using these tags. Your security solution should be able to consume and enforce based upon the tagged information that already exists in the cloud providers. And lastly is visibility. This is not to sit here and say that the native firewall or the native WAF that the cloud providers have is no good. But if you can't effectively see what's going on, troubleshoot, get access to the logs or the packet captures, log in and be able to do a TCP dump and see what's going on, you don't have the right security. Remember, we deploy the security to both protect the assets and see what's going on. So I encourage you to talk to all the vendors in the room. Ask them questions about their cloud platforms. See how portable and dynamic and agile that they can be. Because the truth of the matter is that we are moving to cloud whether we want to or not. And we can either get in the train and go along with our DevOps guys to the cloud, or we can get left behind. Really appreciate you joining for my session. You guys have been a great audience. I'll be around throughout the rest of the day, both here and in the pavilion if you want to ask more questions. Thank you again. Thanks to our hosts and our sponsors, and have a great day.